Today we're doing 5th grade math, lesson 7. So the first section says to compare using greater than, less than, or equal to. So the symbols would be greater than, this would be greater than, this would be less than, and this is equal to. So what I would do is I would start off with the first digit. So in this case it's 1 and 2. Automatically we know 2 is greater than 1. So the answer would be 1.5 is less than 2.5. And the way I like to imagine it is that this is like an alligator. An alligator is eating like the bigger number. So number 2 says 1, -1. Now in this case we know that they're both 1, the first digit. However, this one is negative. Negative will always be less than positive. So in this case, the positive one is greater. So it will be 1 is greater than -1. So we have -2.5 and 0. 0 is always greater than negatives. So it would be -2.5 is less than 0. Number 4 is -3 and -1. Now the way I would imagine this number is that for negatives, it's kind of the opposite. You want a smaller digit for negatives. So -1 million would be actually, -1 would actually be greater than -1 million. So it's kind of the opposite. And another way is that you could draw a number line. You can imagine 0, and to the left is -1, -2, -3. Obviously, -1 would be greater. So -3 is less than -1. Same thing for number 5, greater than. And in this case, 0.5 and 0.5. We know these are the same numbers, so they're equal to. Okay, so now we're doing problem solving and reasoning. Number 7 says that on a cold day, a thermometer showed -10 degrees Fahrenheit in the morning, 4 degrees Fahrenheit at noon, and -5 degrees Fahrenheit in the evening. Order the temperatures from lowest to highest. So what I would do is I would first make a number line. It's like a technique you can use. 0 in the middle. We have 2, 4, 6, 8, 10, and then -2, -4, -6, -8, -10. So we have -10 right here in the morning. So I would circle this, put morning. 4 degrees at noon. And -5 to be like right here in the evening. So now we know which one is greatest. It's morning, evening, and noon. Or we can also write -10, -5, and then 4 degrees Celsius. Or sorry, degrees Fahrenheit. Number 8 says the temperature at noon decreased by 15, I'm assuming degrees. The temperature in the evening decreased by 1, and the temperature in the morning stayed the same. Now rank the temperatures lowest to highest. So we know that the temperature at noon was 4. So 4 minus 15 would be -11. So this would be for noon now. So the temperature evening decreased by 1. Evening, so -4 minus 1 is -5. And now the temperature in the morning stayed the same. So -10 is morning. So now we know that -10 will be the last. Then it will be -11, or -11, -10, and then -5. So we're moving to the next section. It says create and use a table to solve the following word problems. Number 9 says Advi can choose 3 toppings for a sandwich. There are 4 toppings he likes: cheese, tomatoes, cheese, tomatoes, onions, and peppers. How many ways can you order a taco with 3 different toppings? So what I would like to do is I would have a table cheese, tomatoes, and onions, and I would put I would go cheese, tomatoes, onions as a combination. So we know cheese. Oh, sorry, yeah. Let's just do like this. But actually, this one is kind of weird. So we'll actually just go to number 10. Number 10 says at the Pizza Palace, small pizzas are $12 and large pizzas are $9. She paid $45 in total. How many of each size did she buy? So the way I would think about it is if there's different ways to answer this problem. There's no outside information kind of this problem, so there's multiple answers you could use. However, we know that if let's say we only bought one small pizza, that would be $12 already. 45 minus 12 is equal to 33. There are no multiples of 33 that are 9. So it'll be 9, 18, 27, 36. So 33 will not fit. So we know she has to order more than one large pizza. So maybe she bought 2 large pizzas, or 2 small pizzas. That would be $24. 45 minus 24 is 21. 21 is not a multiple of 9, so that wouldn't work either. The only possible way would be 3 small pizzas, which would be $36. 45 minus 36 equals 9, so we have 1 left over, so 36 plus 9. Another way we could solve this problem is we could just do 9 large pizzas. 9 times 5 is 45. So the 2 possible answers, I would say, are 3 small pizzas, 1 large, or 5 large pizzas. These are the 2 most realistic methods. Number 11 says, or we'll just move to number 12. This Aaron has $3 more than Tamara. They're at $23 to pay for dinner. How much money does each person have? So the best way, honestly, to just do this question is guessing and checking. In simple terms, Aaron would have $13. Tamara would have 10. That adds to 23, and Aaron has 3 more. So Aaron, Tamara.